Welcome, everybody. Happy Monday, July 22nd. You are watching mock interview number 105, featuring Jake, who is a software engineer and a recent bootcamp graduate. My name is Albert. I am your host and the founder of Albert's List, your job search and side hustle community where you can find your next job or the next thing to make you more money in your life. So our mock interviews are usually like this. We are here with Phong, who is a career coach. He helps software engineers master their job interviews, which are even harder than ever, given the amount of talent that's currently on the market. Phong is back with us, and what he's going to do is he's going to ask interview questions and then offer feedback from Jake as Jake answers those questions. You all, as the attendees, can offer your feedback and answers or interest as well in terms of asking your own questions, and we'll go from there. So Phong, thanks for coming back. Always good to have you.
Yep. Make an intro first. My name is Phong, as Albert say. I've done tutoring for software engineer interviews for about 2 years now. That's kind of my side job that I do. On the full-time job, I've worked at a number of different companies, from very large to very, very small company. Currently, I'm at a Web3 crypto company. Yeah, that's kind of the long and short version of it. I've done interviews myself on an interval of every 2 to about 2.5 years or so. More so to keep myself in touch with what the industry actually is and how difficult it is to kind of get through certain rounds of interview. But yeah, that's kind of my intro. Go ahead, Jack. Give us a few sentences about yourself, and also, just talk a little bit about your experience and things like that. Yeah.
I'm Jake. I'm from Colorado Springs, Colorado. I was actually born in California, so love it out there. See that you guys are from California. I started programming about 3 years ago. I had a roommate who was in a computer science degree at the local college, and I honestly really just thought it was cool. So I started doing like Leetcode, Code Wars, stuff like that, teaching myself Python, just mainly for fun. And then after a little bit, I started hearing from multiple people about how they were getting jobs as self-taught engineers or bootcamp engineers. And so I started pursuing it a lot more seriously. Since then, I've taught myself to use a lot of different technologies, such as the Rust programming language, which is by far my favorite. Use Django, a lot of Python, AWS, Linux, etc. And I went to a full stack development bootcamp focused on SQL, Django, SQL, Java, Spring Boot, JavaScript, and Angular. I graduated from that, and since then I've been looking for a programming job. I founded an LLC to consolidate my freelance work, and yeah, just working on exploring the industry, the terrain, and learning as much as I can.
Cool. The first question I have is, it looks like you've touched a bunch of different languages. Are you looking to kind of specialize in some of them, or you are trying to kind of keep them more, the generalized aspect of it?
Yeah, absolutely. I'd like to specialize in Rust. That's what, you said you work for a Web3 crypto company. That piqued my interest because a lot of those companies use Rust. Yeah, Rust is, I'd love to specialize in it. It's kind of a niche area though. So I also would like to be, if that doesn't work out, specialize in Java, the Spring Boot stack, something like that.
I see. Yeah, Rust is pretty popular in Web3 for whatever reason. It seems like people just kind of gravitate towards it. We use we don't use Rust, we use move code. It is a Rust-based language now. So if you look at it, you kind of understand, like the double semicolon and stuff like that, like those kind of syntaxes. Cool. Why Rust?
So I originally learned Rust because a mentor of mine who was a self-taught engineer at Microsoft had said that he gave me a few ideas for projects that would be good to develop my skills. One of them was a ray tracing engine. And that at the time seemed the most interesting to me because I mean, I've played video games since I was a kid. Ray tracing is pretty big when you play video games. And so I started to kind of look into it, what I would need to do, and to be efficient, need a systems level language. So then it really boiled down to C++ or Rust. And, C++, it seemed really cool, but there seemed to be a lot of like hype around Rust coming up. It was starting to get popular. And so I kind of just, on a whim, decided to start learning Rust. And I really liked it. I like the syntax. I like the way the language works. So yeah, it's honestly just an interesting language. It's a cool concept.
Yeah, the reason I'm asking is because as you said, and I know you're aware of it too, is that it is not one of the more popular languages for sure. I mean things like Java, Kotlin, JavaScript, stuff like that are going to be a lot more popular. So I would kind of be more aware of what the market looking for, because with Rust, you are going to kind of be fairly limited to like Web3 companies. And even then you are doing fairly specific stuff in it. To be completely transparent, even though I work in the Web3 companies, I actually have not even touched the Rust and the move code layer of it. So keep in mind, if you pick one of the more popular languages, um, you're kind of like you're in get like you just have more windows of opportunities in general. So keep that in mind. It's okay to have a favorite language, and I mean I don't know if you heard that saying. It's like every software engineer knows some guy that really loves Rust for some reason. That's kind of that's kind of one of those things. I mean I know a few people that are like that, but just keep that in mind. It's kind of like a general advice, right? Like if you ask me what to do for like the quickest, easiest in for a job, I would say learning Swift or like Objective-C is probably the best thing to do next to JavaScript, just because there aren't a lot of like iOS developer like at all. It's actually a very hard to find one. So keep that in mind. Just put that out there. But yeah, keep that in mind. Sometimes
Right.
you just gotta balance
Testing out
between
a lot.
between your hobby and what what the market is asking for, right? Like yeah, because if you know Rust, a lot of it is what is going to happen is that a lot of the job you work are going to be like on like the server side of things, and it's going to be a lot harder to break in with lower amounts of like experience in general. So if you work on like the UI stuff, it's a lot easier to break in and then pivot to something else.
Yeah, definitely. Yeah. I've seen that a lot while I've been applying.
Yeah, just that's like if you look for iOS, tons of them because the reasons that nobody wanted to learn like Objective-C and stuff like that, like the C kind of like the permutations of C sharp, it's not fun, so people were just don't. But now you have Swift, so it's a lot nicer. So I would consider look into that, open you a little bit more. Okay, cool. Next thing I want to ask is you mentioned the project you do. Were you doing that by yourself or you work with someone else on it?
On which project?
The the ray tracing stuff, like just kind of yeah.
Yeah,
Talk to me about that one, Jim.
that was a solo project. That was my first, I'd say, big project. It took me many months to complete it. But yeah, that was a solo project.
I see. Do you consider like publish that at some point, you know, or like use the knowledge of that, maybe you know, put the like look for things that like open source projects that are similar ideas and see if you can contribute to that. Have you thought of those kind of pathways also?
Yeah, I did. I think that after that project, I realized that I don't want to be in the computer graphics space. It's not really the industry that I'm interested in primarily. But a lot of the projects that I've done and that one have been more just passion projects because I was curious and wanted to learn.
Okay, that's good to know. I think the one of the best way to kind of learn and get more just things under your experience is to just contribute to like open source projects. If you find something good, work on it. If you actually can count as your experience because you are working with, you know, actual real world professionals, and also like you can kind of understand like the review process and stuff like that on how to, you know, ship your code out. And if anything, for what it's worth, those open source projects have a lot more scrutiny than, you know, even actual code in companies, just because everybody see it, you know, like lots of people's gonna comment. It's a good learning experience. Just yeah, if you like something, I would also suggest doing that way too. Cool. Let me see. Have you had an experience working with kind of like in like a larger group, maybe, you know, two to five people? Yeah, and if you do, what are kind of like your experiences with them, and some of the learning things that you get from kind of like working with the larger groups?
Yeah, definitely. I have. And I'd say the biggest things that I've seen in that is good communication. It becomes really important. And as well as like task delegation, who's going to take care of what and how we're going to structure it so that people don't have to wait on X code being developed and the API can be there to at least in structure to rely on.
How did you deal with the situation where you need both the, say, like the API side and both of the like the front end code to be developed in parallel? How do you handle that, or how does the team work around that? And do you give any sort of input on the workflow around those?
Yeah, so for yes, um, I did two projects that were like that. One, I was our database administrator or mock database administrator for that project. And in both of them, what we really focused on was we created the database schema first. We were using an SQL database. We created the schema, really outlined what data our project needed to function to support the user experience. And from there, we modeled what data needed to be transmitted to the front end. And we went through and we created APIs that we could just outline kind of like what data will be produced, what it will take in. And we created a API documentation through that. And there were times that we needed to change it after it had been defined, but for the most part, it did help us to avoid a lot of those situations.
Okay, cool. Okay, let me see. Okay, so that's good. I give more feedback and stuff in the end of it, but for now, let's move on to like the more technical stuff and just see, you know, where we get to within the next like 34 minutes or so. Okay, so are you from? I mean, well, I'm pretty sure everyone is familiar with things like Fandango or like Ticketmaster, stuff like that, right? Like just a Ticketmaster booking system, right? So for example, and the basics is just you go to the website, you can search for some show that you want. For example, Taylor Swift, right? You get a list of her shows, and then you can click on one of them, then it open up, like say like if I want a show on August the 2nd, it showed me the arena that is, and like what seats you can pick and stuff like that, right? That's generally the flow. However, you run into issues that like for Taylor Swift, you go in, you will, or anyone that's popular, like Drake, for example, you are going to get a huge influx of people trying to book, right? So this is the question's going to be around this. First of all, how would we design a system for booking tickets in shows? And if we have time, we go into kind of more in depth. How would we handle situations like a Taylor Swift, a Drake concerts, where you might get a very, very large influx of users trying to book a same seat in the same date in the same arena, right? How would we handle this in a more meaningful way? This is kind of somewhat an open-ended question because even Ticketmaster with all their resources cannot figure this out, right? Which means that with 40 minutes, we might not get all of it through, but I want to see if you are the one that make the decision, how would you go about doing this? And yeah, you can use any drawing system. You can use Excalidraw if you want to, or anything that you are familiar with. I just drop Excalidraw into the chat if you want to use that, and feel free to share your screen, and we can go.
Awesome. Okay. Yeah, so Fandango, it's funny because I have the programming meetup that I go to once a month had one of our members works for AXS,
Oh,
and
nice.
that was actually an issue for them that they
Did you,
were concerned about.
yeah, did you ask him how come they never fix it? Why is it so bad? Artifact.
He he has a lot of problems with that system too.
Yeah, yeah. But let's see if if we do from scratch. Let's see what we can do with to
Yeah,
overcome this, right?
definitely. So, okay, first off, what is our user throughput going to look like at the most? How many
Okay.
are we gonna have in our database?
Uh, let's say that every day you have, let's say like every city, I mean cities, let's say every state you have like something like 10,000 shows a day.
Okay, so 10,000 shows a day, that's 10,000 people buying tickets each day?
Shows, it shows can say it shows we have 10,000 seats. Let's make it in 10 of that. Yeah, 10,000 shows a day, 10,000 seats per show.
Okay. And what are we looking at for the amount of users that we would have in our database total? Like accounts, user profiles, stuff like that.
I see. Up to you. Just give me something that makes sense.
Okay. Yeah. So I would say for a medium size app, maybe we have 1 million users in our database.
Okay.
Awesome. And then we're going to have
Do
shows.
users need to have an account to buy tickets?
Yeah, so that is a good question. I guess you could have some sort of system where it goes through to an email, but I think for reliability, consistency, and security, it's generally in this kind of situation, I think it'd be a good idea to have an account for a user.
Okay. That's fine. Yeah.
And so we're just focusing on
Let's make it 10 million users because 1 million user for like 10,000 shows is kind of small. So yeah, let's leave it
yeah,
at that. Yeah.
that's a good point. That is a good point. And then for shows, I'd say we're probably, if we're doing 10,000 shows a day,
Mm-hmm.
10,000 shows a day, shows. And so then that will probably be something around 3,650,000 shows each year.
Yeah, you can make a ballpark, so say like 300 million. Make it 400. Yeah. Yeah.
Okay. And then for show, we're probably going to have a show's, let's say, a megabyte, just for all the metadata.
Okay. So that means like the info for each of the shows, like they just show info, casts and stuff like that. Is that what all these metadata is?
Yeah. And
Okay.
what I'm just looking at is what are our metrics going to be so that when we are outlining the more technical details, how can we support those metrics?
That's okay.
So awesome. And so the priorities are just going to be just purely shows and people buying tickets to those shows. We're not going to have sorts of promotional stuff or anything like that. We're just going to keep it simple to those two things.
Good question. Those can just be like non-functional requirements, things that we might add on, but we don't need to kind of take care of it, right?
Okay. I like that. Metrics.
Like good to have kind of stuff.
Definitely. Yeah. Always MVP and then expand from there, right?
Yeah.
So non-functional recs. Okay.
Okay, and some of the important things for the metrics of functional requirements is that it has to be highly concurrent. That means that many people need to be able to shop at the same time, right? And it has to be highly durable, which means that if I have a ticket in my cart and my cart crashes, that's very bad, right? So so you cannot have crash cards. That's another thing. It's also should be able to handle things like digital payments, right? Things like credit card, PayPal, stuff like that, right? And maybe some sort of notifications, right? Like after the user check out successfully, it might send like, I don't know, like a email, text message or something that say like, hey, this is your tickets, right? Those are also the things that I think we should talk about briefly in the thing, right?
Okay.
In the
Yeah.
overall design, like where can we put these and stuff like that. But I think these are the more or less some of the important thing we should kind of deal with, right? Because without any of those things, I don't think the system is considered working, right?
Yeah, definitely. Those are very important to user experience. I agree. And so with notifications, you're talking about, you said something about apps. So that makes me think kind of what are going to be the interfaces that users will interact with this? Are you going to have mobile apps as well as an online web app? And then just kind of keep it to there. We're going to have more ways for
Yeah,
them.
just make it a simple like a spa is okay.
Okay.
Like, yeah, mobile app or yeah, things like that. Just keep them simple.
Okay. Let's see. So we're gonna have shows, ticket, and then we'll probably have tickets. So tickets for users. Let's do users at 1 megabyte. So So 4 million megabytes plus 14 million megabytes. That's 1.4. No, yeah, that's fine right there. Okay.
It's like 40,000 gig or something like this, which 40,000 gigs.
Yeah.
If you
Okay. 14,000.
which is a pretty small number in all.
Yeah, wow, that's crazy. That's only 600 away from a terabyte. That's a lot.
Yeah. Yeah,
Yeah.
I mean you can make your, for what is worth, you can make your like data smaller by not having each of them is like the whole megabytes. So you can, because but that's fine. Just don't over index on the sizing. It's okay.
Okay. Awesome. So yeah, how do we feel about this? How do you like where it's at for just functional and
Yeah.
potential non-functional requirements?
Yeah, I think that's okay. Let's go into just draw out some like how the flow will be and what are like kind of like some basic APIs from the server and stuff like that.
Awesome. Yeah. So I'd like to start with the database, just kind of, we're going to need a database. And for me, being highly concurrent, we're going to need something that's ACID, that stands up to ACID specifications. So that strikes me as it would be good to have a SQL language system, but something more like CockroachDB or, one of those databases that is able to be spread across multiple servers, but also use an SQL language, use SQL as its query language.
Okay. Okay, that's good call out on the acidity of it. That we need to keep it as ACID compliant because of the concurrent. However, one thing that I would ask is, this are you going to put all of them in here? That's my question because the shows, because the data form of the shows, right? It can be very random. Like you're gonna have different like production companies provide you with the data, right? The data can be very free flow. So would NoSQL is also might be better? This is not a right or wrong answer. I just want to hear your opinion on this. How do you handle with the free form data?
Yeah, definitely. That is a really good question. I think that to me, the thing that strikes me as important for having an ACID compliant database is something like double booking being a problem, where you maybe accidentally sell two people the same ticket. And from what I understand, that can be a problem with data propagation in NoSQL, well, in like MongoDB and database.
Yeah, I mean, if you are afraid of that, you can always just implement your own locking system, right? You can do like a double locking, like a two-phase commit mechanism that will kind of pretty much like you commit and then you check and then you commit. It's slower, but it's doable. Again, it's not a right or wrong answer. You can also just use a mix too, right? Like for the transaction itself, you can use the RMDBS like a SQL, but for like the data itself, you can just stuff them in like a NoSQL, right? You can
Okay.
always reference a different database, right? Like you don't have to have the same thing everywhere.
Yeah,
Right,
honestly,
right.
that's
Because when you write a query, say if you write a query for like a movie, you can just query your something else and then you just batch them together and send it to the front end as like the whole block, right?
okay. Yeah.
But you
Yeah.
can always reference that by
Good
the ID. Yeah.
to bring up because yeah, I mean, I think that if you can have stuff that's coming from like different different people making the different production studios or whoever's taking care of setting up these shows, if you have different data, then that data itself could be really useful to have if it's in a NoSQL database while having the things that we are accessing and modifying on a consistent and constant basis with high throughput being in a SQL.
Yeah.
More non-traditional SQL is what I think, like Google makes one. It's similar to CockroachDB. I forget what it's called right now.
Is that no, it's not big table. Big table is in NoSQL. Is it big table? I don't remember.
No, they use SQL, but it's it has a strong emphasis on horizontal scalability. Um,
I
yeah,
see. That's interesting. That yeah, okay. That makes sense. I mean, people have to figure out how to horizontal scale it, SQL today. So.
right. Yeah, and it's SQL is just so invested in um, horizontal scalable.
Yeah, and the horizontal scaling of SQL that is a little bit of a weird dichotomy because SQL, you can't really scale them horizontally. If they are doing that, that is something else probably because you look have you looked into like the different database, right? Like SQL in its form is not horizontally scalable. It's only vertically scalable. So for them to make it a horizontally scalable SQL, it might be something else. Might be something else that looks like an SQL, but yeah, that's just something to keep in mind. Yeah.
Yeah, I think that is what they do. It's just SQL for the query language.
Mhm.
Forget what that is.
But
Cockroach
but
one
but
that
if but if it only SQL for the query language, then it is not really an SQL database, right? That is something else. That might just mean they might just use like a wide column table that make it looks like an SQL. So
okay,
yeah,
yeah, I
keep that in mind. Yeah, because you cannot horizontally scale SQL.
okay.
Yeah, if you look up, like SQL and difference between SQL and no SQL, that's one of the things. SQL you vertically scale. Like you can horizontally scale SQL, implying that you just shard them. You just do like database sharding. So assume that you are database sharding with SQL. How would you handle things like you might shard things like if the ticket if I want to book 5 tickets on row 200 and the 5 tickets might be on different shards, would that take a long time for me to query them?
Um, do we know like what so are the tickets to the same show?
Yeah, for the same show. Say if I want to book Taylor Swift August 2nd at someplace, Las
So
Vegas Arena or whatever.
we could assume that the front end has the knowledge of what maybe there's a hash to the ticket, and the front end has that data. And then you could do something like a hash table to access those shards, where it's constant.
Hmm. Let's swing back to this issue later. Keep going then. Then let's swing back to this issue because there's some problems with it. But yeah, just keep going on your. So we use a SQL system that we're going to horizontally shard up. What else are we going to do this?
Horizontally sharded, and we'll just pretend that's a word. And
Yeah, I don't even know if that's the word. Just
yeah,
just saying.
okay. And then this will be specifically just for the tickets and then for
You don't even have to do it for ticket. You only need this really for the transaction itself. Because in this one, you only need something like you only need to store in this one transaction ID, and then you have ticket ID. It can point to some other table or database system completely, right? And then you can have user ID that point somewhere else, right? You really only need this asset for the transaction.
okay, yeah.
Right,
All right.
right.
Yeah,
That's the most important thing,
you
right?
can have for everything else. It just, and I've heard that MongoDB, like NoSQL DBs that are like non-MongoDB are just easier to work with too. So
Yeah,
then,
they're a lot easier to work with. Like things like Cassandra and Mongo is because they are key value pair almost. So they just like they look like an object, so it's a lot easier to deal with. Yeah.
awesome. Yeah, that's a really good benefit to have on hand too. Just for that was the other thing that I forgot to ask is kind of for this application is the budget. What does the budget look like? Is it really high? Is it low? Is it generally in the middle?
It's for like a mid-sized company. Let's not, yeah, don't have to worry about the budget for now. Let's go through with the actual design of that. Yeah.
Okay, awesome. And then so what I would say is that for the transactions, you're going to want something that is probably fast. This is where you'd write your server in Rust or C++ to take care of those. Does that sound about right to you?
Uh, so yeah, yeah, you can do that. Yeah.
So we'll have our transaction server, and we'll just copy that to make it look like there's a bunch of them.
Mhm.
And that will communicate pretty much directly with the database. So then the only thing is I'm just trying to think right now if we would have any situation right here where we could use a cache. But I think that just seeing where it is right now and then coming back later to see if I notice any bottlenecks would be probably the best way to go about that.
Okay.
The transaction server will communicate with that server, and then we'll have just a regular server that is able to handle everything else, and it would probably be monolithic just because for medium-sized companies, that's generally best.
Wait, what do we want to do what do we want to do that? What do we want to do a monolithic server? I
Because I've seen that there's a lot of, well, you could do monolithic or you could do microservice architecture for this. And those are the two that I'm really thinking of. And the reason I would say monolithic for this is I've seen a lot of stuff coming out from companies like Amazon, Google, these larger companies where they're starting to move back to monolithic architectures for medium-sized projects. And there's also been a lot of companies that I've seen who have had troubles with microservice when they are a medium-sized company.
Okay, that's a fair assessment. Yeah.
Yeah, just keep things simple
Mhm.
when you can. Is why I would think to do that. And then we will then from here we have a front end, and I would think that we will have a mobile app, and this will probably be in a platform specific language, and then we'll also have a front end web app, and this will be, well, let's just say Angular. And so how these will communicate, I would think, is that we would have the mobile app and the front end web app will directly communicate with our main server for the most part. And that main server will direct the mobile app to the transaction server when necessary so that we can take care of those transactions happening.
Okay. Okay, this looks like a reasonable basic thing
Yeah.
that we will set up, right? Okay. So here's a question's gonna happen. So what if, say, if it is a Taylor Swift concert, you are going to get a lot of traffic. In that way, your monolithic server might crash and stuff like that. How do you handle these things? So let's try this out. How do you handle things like when the user, if I'm able to click on a ticket and I check out, what usually happen? It will have kind of like a block that it will tell me I have, say, 5 minutes to buy the ticket, right? If I don't buy in 5 minutes, it's gone.
Mhm.
How do those get handled? How does that work? And how do you handle just say a ton of people? Say like, because right now, right, we assume that all the traffic coming into the monolithic section of it is stable. But what if you get, say like if say like you might have a huge influx in the West Coast locking in and it will crash your West Coast clusters, what will happen? How do we handle these cases? So let's talk about how do we handle that's kind of heavy traffic and how do we handle things like when I'm able to click the ticket, you say 5 minutes and then I have 5 minutes to check out. Pick one of them and then we can talk about one of them at a time.
Yeah, definitely. I think I'll start with load balancing as so you're going and you get a sudden surge of traffic. I think that the best strategy would be to choose a lowest throughput, a combination of lowest throughput and like closest to the user load balancer for both the transaction server and the regular monolithic server.
What if you get like, what if like 80% of traffic, say, coming from California?
Mm.
And this might be a known quantity. Say if 80% of traffic is going to come to California, and if you just leave it to the fate of the load balancer, they will just randomly crashes, and then you just kind of pray like, oh, hopefully it will route correctly.
Okay. And so, well, you need a way for your load balancer to keep track of what servers have the least thing that's real time. And then it would need to route based on that.
Can you handle it more elegantly without just hoping that the load balancer will take care of it? Because load balancer right now is just, you have an algorithm, so you have round robin, or you can even have like list connected or whatever, right? But that's still kind of letting things happen. How do you prevent this from the load balancer to crash? Because right now you are still waiting and you know that your load balancer is just gonna crash, and then like automatically redirect. But you know this. How do you go about to not seeing it crashing down?
Yeah, okay. So I think then the best thing would be to have a front end queue. Your front end communicates with the server. Some servers keeping track of this and says that it's just not happening right now. Nothing's able to
Okay.
get, and you'll have to wait for the queue.
Okay, so you have a queue. What is your purpose of this queue?
Um, I guess the purpose would be to limit the amount of load on the servers and the load balancer. And so that would need to probably be calculated based on how much combined the load balancer and servers can take. And from there,
I see.
some way to keep track of that would need
What
to
if, okay, let me propose this. What if, say if you have an arena for 10,000 tickets, right? Or say 100,000 tickets arena, right? And 80% are going to be 80% of traffic gonna show up on, say, the West Coast, right? So that means that what if we just allocated the 80,000 out of the 100,000 ticket for the West Coast? And the usage of the queue is good in the sense that I would use the queue this way. Say if we have 80,000 tickets for the West Coast, we can split it up into, say, a different queue. Each of the queue has 10,000 ticket on it, right? And then we can spin up a cache and a server that will say, like, on server 1, we have ticket from number 0 to 9,999, right? And then on server 2, we have from 10,000 to the next 10,000 chunk, right? You just have queue like that. Then when the user go into the queue, what happens is that they will join one of those servers. Like, you have a load balancer that will distribute them into there. If it's more than, say, like 10,000 user on one server, sure, just put them on the queue. If someone drop out, the next person go in, right?
Okay. So
Right.
kind of fragmenting those queues.
Yeah, you break out the ticket. You pre-allocated the ticket before you even let the traffic breaks the system.
Okay.
Right. So say you 80% of the 100,000 are going to be on like a region, and you allocate, say, 80% of those tickets, right? Then you break them into you pre-allocate the ticket into the server. So each of the server can have its own, like, little database to keep track of how many tickets they have on that clusters.
Okay.
So when you hit the load balancer, you just send them to one of those little servers first, and then you just deal with things in there.
Okay.
What happened is that you can have like a async worker that occasionally check how many tickets that server 1 have, how many tickets server 2 have, how many tickets server 3 still have, right? And when users join, you just join them to, like, those servers. Because right now with your designs that you have everybody hitting the monolithic server at the same time, right? And then you try to do transaction, all of them is gonna do, like, you're just gonna get a ton and a ton of people there.
Yeah.
I would say that for this system design, you want to think of the way to how do you, like, fragment them in this situation, right? You're gonna run into the questions like, how do you deal with, like, huge traffic, right? Like, yeah, load balancer is kind of like a dummy way to be like that, but that should be like your last line of defense before, like, everything explodes, right? But the best way for this, I think, is to fragment them out, right? And just pre-allocate tickets.
Okay.
I mean, there are other ways to do this too, but this is one of the way that I think would be useful to handle that kind of low traffic coming in.
Right. And so that's just for the tickets, right? It's not the transactions, like, well.
So each of the, so you break into a different chunk of server, each of them holding 10,000 tickets, right? So you just do the transaction within each of. So that means that each server at any given time, the most they would handle is 10,000 transactions.
Yeah.
Because each server only have 10,000 tickets, right? At most, you have 10,000 people checking 10,000 tickets out at the same time. Right? So at 10,000 transactions is very small. Right? It should be able to handle that, no problem.
Yeah. Yeah, keeping it well below the load so that
Yeah, exactly. Yeah. Like you can use anything for, like, each of those little server can have its own like it can call its own like transaction server like service in the back to do that. Yeah, and that's something that you want, you can go more in depth of how that works too.
Yeah, definitely. And then
But does
that's
that make sense? Does that make sense of how I propose the way to like fragment them out? Would you have any
yeah,
questions?
absolutely. That does. And just essentially like limiting the amount of load that the amount of work that the so keeping the load balancer as a catch-all in case nuclear,
Yeah,
and
yeah.
then in advance limiting the amount of load that each server will ever have to take.
Yeah, because if you assign 10,000 tickets to them, you know for sure that at the most of the time, that's they will handle 10,000 transactions, right? Yeah, it's just more manageable that way, rather
Okay.
than have like everybody hitting your cluster of monolithic server at once.
Right. Yeah. So and then that almost to me strikes as like then at that point, like, do you want to have a microservice architecture?
Yes, there you go. Yeah, you
Yeah.
do. Yeah, that's why you want that to be its own microservice, right? It's just like you just dynamically spin up how many of those little servers you want to kind of front load the user. And those numbers are known, right? Like you know how many tickets you're gonna have, and then you have historically how big the traffic would be for certain shows, right? And then you just kind of just microservice and set things like your goal is to generally not hitting the database so fast, right? Because with this setup, it's like the database is right there, right? You don't even have to check the database to sell the tickets to people because you already pre-allocate the tickets to each of those servers already. Like,
Yeah.
have you noticed that even from Ticketmaster, once in a while, even when the tickets are sold out, after a while you will see like tickets showing up again. Is what happened is because some of the cluster didn't sell out, they will redistribute them.
Oh, okay. That's
That's
pretty
what
cool.
you right. That's why suddenly sometime like maybe an hour later you're like, oh, some random ticket will show up. It's because sometimes things like that happen because some cluster didn't sell out, they will redistribute them.
Hmm. Okay. Yeah, that's really cool. Yeah. Yeah, no, totally. This seems like definitely a perfect situation for a microservice architecture. Uh, so, I mean, here we would have a microservice that takes care of just the transactions, um, or not just the transactions, just the ticket tracking.
Yeah. Yeah, and then each of those just, have its own database, right? And you just pre-allocate certain amount of tickets to each of them.
Okay. Yeah, definitely. Let me put that in there just because that is an important part of that. Pre-allocated ticket fragment. And I'll put this over here just because it's
Mhm.
easier to have it with all of that. Um, so that will have its transaction tracking server, so it can kind of keep track of, where should we send this person, and would that communicate, and then that I think could communicate with its own load with the load balancer, more of like a custom load balancer.
Yeah, exactly. So you want to limit the downstream system getting hit so much, right? As much as possible.
Right? So
And I
custom.
mean, something quick, we're about to run out of time. So let me ask a few other questions. How do you handle things like notifications, for example, in this setup right now? How would you, at what stage is you actually do the notification?
Okay, yeah, I think that this would be more like you have your servers that take care of transactions and ticketing, and they're, separate from your servers that take care of user info, of displaying like certain things like, more related to the user, logins and whatnot. Um, and I think that that would be kind of a webhook on that side of things, that would communicate with a with the mobile app or would send out emails.
Yeah, and generally you probably want to do that in like where the transaction server go into the database. Like you can just, because when you write there, you just probably put in the right queue, and then when it write, you just send it to like one of the services that do like a notification or SMS or whatever, or email, whatever you want, right? Like MailChimp or something like that. Yeah.
Yeah.
Cool. Cool. Any question you have before we close out? But this was good. I would say you kind of understand the basics of it. This I would say this is a pretty difficult problem because you run into those kind of questions, right? Like how would you handle things like just like crazy traffic, right? And it's fairly specific to how this one is handled. You might get questions like if you have to deal with like an e-commerce, like an Amazon storefront, right? They might ask you questions like, on Prime Day, what are we doing? How do we deal with like the very, say, like popular items, right? You do that kind of the same. You break them down, and then you kind of pre-allocate it to certain like clusters with how many items they can have, and then those are the things that usually help you handle these more like a heavy traffic. If you can anticipate the traffic, you want to kind of pre-allocate stuff just before people even, and you can even do like a wall garden sort of thing where you just kind of spin up a bunch of servers just to make sure it doesn't go down, right? Like that's just, but pre-allocation is fairly useful for situation like this. Right? I worked through Black Friday at an e-commerce before, so that's exactly what they do. They spin up a bunch of stuff, they pre-allocate it, and then see if it's gonna break. That's what they do. Yeah,
that's cool. Thank you. This has been really helpful.
Yeah. Oh, Albert said, could you recommend doing in order to get better system design? I would say just read books on how system designs are done. The hard part of system designs are that there is the right and the wrong answers at all time. Like even if it seems ambiguous, like this problem, there are certain way to kind of tackle that, right? And that's kind of what I want to get out of this, is that it's just the fact that there are a lot of videos that you like, just YouTube videos or things. I would say things that you see on day-to-day basis. Just kind of watch the video on how they work. Things like Zoom, for example. How do they do this? Be curious about stuff and just watch like a 30 minutes, 60 minutes video about how these things are built, because chances are that you will get asked them in an interview, things like, like how do you build Zoom? How do you do like Facebook messengers? How do you do like Uber ride sharing matching, right? Like how do they match the driver and the rider? That's can be a question too, right? So just kind of, when you see something that interesting, that seems simple, kind of think, how do they do that? How do they handle those kind of situation? I think it just, there's no way around how to get better with this. Is really just watch my videos and just see how they work. They're like podcasts and stuff. Sometimes like some companies even post them, how they build their system, how they change stuff. Like Discord posted how they use, I believe, like they did like a migration recently that helps a lot with cutting down the database, things like that. Read them, it is helpful. But I say it's more of a cumulative of experience rather than like, a quick one-off answer. Cool. Anything else you have, Jake? Or otherwise, I think that was great. I think you just go through them quicker. I would say one thing that I recommend is kind of write out what API you're gonna use. I think that's important to have also. But I think this was good. Seems like you do know some stuff, but it's just a matter of doing more of these mock interviews. Yeah.
Yeah, I really appreciate it.
Yep.
Yeah, I learned a lot. I gained a lot of good experience from this. So yeah, thank you both.
All right, wonderful. Thank you so much, Jake, and thank you so much, Phong, for being a part of this tonight. If you'd like to be a part of a future mock interview, please let us know. We're always taking technical and non-technical mock interviews so you can practice for your interview in this tight job market. This video will also be recorded. It has been recorded and will be on our YouTube channel, and we'll be following up with that as soon as we have it. Thanks, everyone. Have a great, wonderful rest of your week, and we'll see you again for an event soon. Bye.
Awesome. Take care.